Okay, here we go. Oops, missed it. No, J. Sorry, J. Yep. Right, so now we're doing applications of integration. So there's a couple of things that you really need to make sure you know, right? At least their rules. Okay, the first one is this one here, the average value function. Okay, make sure you know this rule here, because if they ask you to work out the average value between 2 points, then that's the rule you're going to use. That's very important. Okay, so make sure you highlight that, whatever you have to do. So here's an example. Okay, this is, oops, let me clear this. This is exercise 11J question 4. And it says, an object falls from rest, its velocity v meters per second at time t seconds is given by this rule. Now, those of you who do physics, you'll recognise that rule anyway. Anyone does physics in the class? Okay, a couple of you. What's the 9.8 stand for, Theodore?
Gravity?
Yeah, gravity, right? Gravitational pull of the Earth's surface. That's what it stands for, right? Because as we jump, so we jump out of a plane, what's drawing us towards the ground? It is the gravitational pull, right? So that's what's drawing us towards the ground. Okay, now let me go back a step in case you've forgotten. Remember, if we have the distance and we differentiate this one, the distance rule, then we get the velocity rule. If we have the velocity and we differentiate that one, then we get the acceleration rule. And of course, if we want to go backwards, we integrate. Okay, so if we integrate the acceleration, then that gives us the velocity. And if we integrate velocity, it gives us the distance, right? So here we've got the velocity and it says find the average velocity. Average velocity, I'm going to just change my color. Average velocity of the object for the first 3 seconds of its motion. So average rule up the top. Okay, 1 divided by b minus a, the integral between a and your b of the function. So there we go. It says for the first 3 seconds, so we've got time of 3 and we also have a time of 0 because the start time always starts at 0 and it's going for 3 seconds. So that's how we got the 3 minus 0 there. Any questions? Okay, between the integral of 0 to 3 of the function is 9.8t. That's how we've got that. Now here we've got it in terms of time. So we're not going to differentiate with x there. We have to differentiate with t. That's why we've got dt instead of dx. So integrate it. So if I integrate 9.8t, remember I add 1 to the power, it becomes my squared. I divide by the 2. 9.8 divided by 2 gives me the 4.9 between 0 and 3. And 1 divided by 3 minus 0 is just the third. Substitute the 3 in. So 3 squared times 4.9 is 44.1 times the 0 in, I get 0. 44.1 minus 0 divided by 3, that whole thing is 14.7. Any questions there? Okay, I'll give you a little bit of time just to write that down or highlight or whatever, like 10 seconds because the whole question's there. And then I'm going to clear it. Okay, I'm going to clear this and we'll move to the next one. Now this one's talking about motion. Remember, I did say this was a lot of physics stuff, so I'll change to my blue color here. This is question 7 from 11J. It says an object starts from point 0. Now 0 is not necessarily the origin here, okay? It is the point anywhere, but it is the point 0. Moves in a straight line. After t seconds, and remember, since it's time, it has to be greater than equal to 0. We cannot have a negative time. Its velocity is given by that rule. Find its position x in terms of t. Okay, so we want its position. We've got the velocity. Remember what I said. If you've got velocity and you want position, we integrate. So we are integrating for part A, we are integrating the v, the velocity, which in this case, we are integrating 2t minus 3 with respect to t. And that's how I get the t squared minus the 3t. 2t squared, that cancels, you get the t squared minus the 3t. Any questions there? Part B says it's position after 3 seconds. It's position after 3 seconds. Okay, well, we already know now the rule for the position, so we're going to substitute 3 seconds in there. So we get x equals 3 squared minus 3 times 3. When we work that out, we get 0. So it's at 0 meters. Questions there? Okay, I'll give you 10 seconds to clear that again, only because it's written just right to anything down. All right, let's clear that one and continue. Part C says it's average velocity in the first 3 seconds. Okay. Now remember, it's average velocity. Change in displacement divided by time. That's what we're looking at. Average of velocity. Change in displacement divided by time. Okay. Here, we know at t equals 3, we've got x equals 0. At t equals 0, because it says for the first 3 seconds, so we've got a time of 0 and a time of 3. We substitute t equals 0 in the x rule, which I can't go up, but you guys can see it, we would get x equals 0. Okay, change in x, 0 minus 0 is still 0. 0 divided by anything is still going to be 0. So the average velocity is 0. Okay. Change in time, 0 minus 0 divided by 3 minus 0 is still 0. Any questions on that one? All right, part D. The distance travelled in the first 3 seconds. Okay, so let's think about this. This object's obviously taken off, hasn't it? So something's going to happen. It's got to stop somewhere or other. So let's work out where it stops. And of course, where something stops, where this object stops, whatever it is, whether it's a car or not, the velocity at that particular time has to be 0. Because the car's not going or this object's not going. So its speed, its velocity is 0. So we're going to put the velocity equal to 0. And we're going to solve at what time that happens. Because as soon as we find the time, then we can substitute it into the x and find where it is. So that's what we're doing. So I put the velocity, which is 2t minus 3, put it equal to 0. 2t equals to 3, t equals to 3 divided by 2. So 1.5 seconds. That's how I got that one there. At the time of 1.5, or 3 divided by 2, we're substituting it into our x rule, our distance rule, to find where it's gone. So 3 divided by 2 squared minus 3 times 3 divided by 2. Okay, and we simplify that, we end up getting -9 on 4. If you want me to do all the steps for this question, please ask me and I will do it. Okay, now that's only for the first 1.5 seconds. 3 divided by 2, 1.5 seconds. So obviously what's happened, it starts off, it goes for 1.5 seconds, stops, and then what happens for the other 1.5 seconds? It must go back because it's returned to 0. At t equals 3, we know up here in questions 3, part C, at t equals 3, it is back at x equals 0. So it's done this, right? It's done this. It's taken off for 1.5 seconds. It's moved. And then the other 1.5 seconds, it's back to the starting point. So we have to times that distance by 2. The negative, we don't care about the negative. The negative does that not matter. All that negative means is it's gone in the negative direction. That's all. It's still travelled that distance, but we're distinguishing between a positive direction and a negative direction. Does that make sense to you? Okay, so we've got to double it because that's only for the first 1.5 seconds. We need for the first 3 seconds. So we're doubling it and we get 9 divided by 2 meters. Any questions there? Remember, if this drops out, stay on there. If your internet doesn't drop out, I'll just connect back up. Okay, any questions on that one? All right, part E. It says it's average speed in the first 3 seconds. So average speed is the distance divided by the time. Well, we already know our distance, 9 divided by 2. And the time we know is first 3 seconds. So we're going to do 9 divided by 2 divided by 3, which is 9 divided by 2 times 1/3. 3 goes into 9 3 times, so we get 3 divided by 2 meters per second. Any questions on that one? Okay, I'll give you some time, 10 seconds again, because it's all written just to write what you want on there. And then I'll clear it, and I think we're almost towards the end. Okay. Got a little note there for you. It says it's useful to observe that for the time interval, so between 2 times, the average velocity we can work out as that. So that's another little good one to just put in there for yourself. Highlight it, just to keep handy. Right, rates of change. Let me go back to my blue one. This is question 13 from your book. It says the rate of flow of water from a reservoir is given by. And you can see there's a rate here. How do we know it's a rate? Because it's a derivative, dV dt. Okay, we've got the dV dt, so the rate of flow, volume compared to time, that's what's that saying. And there's the rule. I'm not going to read it all out to you. Time is between 0 and 15. V, millions of litres, and T, number of hours after the gates are opened. What does that mean? Okay, so if you look at a dam, they've got the big gates, they raise the gates, the water starts flowing out, they pull the gates down, the water stops. Okay, that's what we're talking about. Okay. Part A says find the rate of flow in millions litres per hour. It has to be millions litres per hour because the original question is millions of litres per hour. Okay, when T equals 0 and T equals 2. Okay, well, I already know this is the rate of flow. We know that. That's what they tell us. And that's what they want us to find at T equals 0 and T equals 2. So we substitute T equals 0 in the rule. T equals 0, we get 1,000 litres. 1,000 million litres per hour. Putting T equals to 2. So we've got 1,000 minus 2 squared is 4. 4 times 30 is 120. 2 cubed is 8. 2 times 8, 16. So plus 16. So at T equals 2, we've got 896 millions of litres per hour. Questions there? Okay, part B. And this is part 1. It says find the times when the rate of flow is at a maximum. So how do we work out if something is a maximum or a minimum? What do we normally do? I need an answer. Off anyone.
Make it equal 0.
No, but how do we work out it? Say we've got a curve and I want to find a maximum. What's the first thing we do?
differentiate?
We differentiate, okay? Same thing here. Just because we've got a rate of flow, how much water is coming out, if they want us to say the rate of flow is a maximum, we must differentiate. So this is what we have, okay, up to here, but I can't show a derivative of a rate, so I've called it R. And now I am differentiating that, okay? So I'm differentiating my rule, so I can work out my maximum flow. Does that make sense to you guys? Okay, so differentiate 1,000, that's fine. Negative 30t squared becomes a negative 60t, and 2t cubed becomes 2 3s are 6t squared. Okay, put it equal to 0 to find out what the maximum is. The maximum occurs at t equals 0 or t equals 10. Now, if those of you that want more steps, here it is. I'm going to do 6t as a factor. This becomes 10 minus t equal to 0. So 6t equals 0, t equals 0. 10 minus t equals 0, t equals 10. Okay, so that's how we got those answers, t equals 0, t equals 10. Of course, which one is it? We have to do our sign diagram to work out which one's our maximum. So I didn't do the sign diagram, but I've just written it here. It says at t equals 0, as we get a maximum, and at t equals 10, we get a minimum. Okay, so if we want to know what it is, we can substitute it in. When t equals 10, we get R equal to 0. So if I put t equals 10 into this rule, I get R equals 1,000. You can check other points if you want, but at t equals, oh no, we've got to check the endpoints. That's right, we've got to check the endpoints because we might have, at endpoints, we might have a maximum as well. Well, t equals 0, we already know it's a maximum. Check at t equals 15. T equals 15, we get R equals 1,000 as well. So we got two maximums. One is at t equals 0 and the other one is at t equals 15. Any questions there? Part 2, which is right here, part 2 says find the maximum flow. Well, we've already found it. It's there, 1,000 million litres per hour. We had to find it anyway to make sure that it was a maximum. So there it is, 1,000 million litres per hour. All right, part C is you guys sketching this, and I've said to use your calculator. So I'll just, if you finish copying this, make sure you sketch it, use your calculator and just copy it across. Be aware of your domain, please, only between 0 and 15. And I'll give you 10 seconds to copy this down, and then I'll move to the next page. I think that's it before I clear it. Okay, let me clear it. I know part D. Find the area between the graph of t equals 0 and t equals 10, and what does this area represent? I haven't sketched it, so let me just get my calculator out and sketch this graph. There it is. Okay, graph. We've got 1,000 minus 30 times. I'm not going to put t, I'm going to put x because the calculator is in x, so x squared plus 2 times x cubed. Okay, I'm going to fix my window. I know it's 1,000, so menu, window, settings, y maximum, or x minimum can be -1, just so I can see things. X maximum has to be 15, so I'll go to 20 just so I can see it. Y minimum, look, we don't need it past 0, but I'll put in -1. And Y maximum, we know it's going to hit 1,000, so I'm going to put 1,100. We know that's going to be 1,000 because we've got our maximum on there. Okay, so there we go. I've done that sketch. I could have stopped it between 0 and 15, doesn't matter. Find the area between the graph of 0 to 15. So I'm going to go menu, And you can find the area. I'm just trying to think how to do it. No, not bounded. This graph. Right, okay. Does anyone remember how to find the area on your calculator? No? Oh, I've got to remember how to do that. I've got to remember how to do the area, so I will tell you that, but it should give us an answer. Has anyone got the answer for the area between 0 and 10? Not yet? It should be, D should be 5,000. 5,000. So that's what I'm going to write down. $5,000. Of course, it is millions. I know that's in part D. So 5,000 is the area under the graph. What does this represent? 5,000 millions litres flowed out. What was this thing? Well, first flowed out in the first 10 hours. In the first, it's not down to 0 because at t equals 15, we're having 1,000 litres of water flowing out. So the first 10 hours, 5,000 million litres of water has flowed out of whatever this is. Any questions there?
Does that mean the after 10 hours it flows back in?
Well, it hasn't hit 0 yet, has it? Hasn't hit 0 yet. When has water stopped flowing yet? So we need to know when it hits, when there's no more water in there. Okay, so when there's no more water, of course, it's not going to flow back in. There's just no more water. It's done. Okay, but we know we've started with. We don't know how much we've started with at all. Okay, but once we've hit, we've used all the water. That's it. And it could be at this time, but they haven't given us enough. All right. So that's that one. That's the end of chapter 11. So now, unless anyone's got any more questions on this, I'm going to move to the questions that people have sent me. And therefore, I'm going to bring up the whiteboard. So let me just clear all this. Okay. Stop this share. Good, we've got everyone. Now I'm going to share the whiteboard. Okay, and the first question that I'm going to do is exercise 11H3B. Exercise 11H, question 3B. This was Natalie's question. So let me go to the question. I have worked out the solutions. So 11H3B says differentiate that and hence find an antiderivative. Okay. So this again is important. This is integration by recognition. Okay, these are one of the hard ones, just like question 4. Okay, so it first tells us to differentiate this. So I'm going to write d dx, and the question is cos 2x divided by sin 2x. Cos 2x divided by sin 2x. Okay, so when I differentiate this one, remember we can use the quotient rule here, and that's what I'm going to use. I'm just not going to write it down, but really it's v u dash minus u v dash divided by v squared. Okay, 1023, we don't have much time, but anyway, that's fine. So let's differentiate this one. If it cuts out when in the 40 minutes, because it only gives us 40 minutes, that means we're almost towards the end of the class anyway, but I'll try and get this one done. If not, I'll do it next time. Just keep bringing me those questions. So leave the denominator, so sine 2x times, differentiate the numerator. So derivative of cos is negative. 2x becomes, when I differentiate the 2x where the cos is, becomes 2, but remember it's 1 divided by that. No, it's not. I did that wrong. It's 2 times. It's negative 2 sine 2x minus, okay, leave the numerator cos of 2x, differentiate the denominator. So this becomes 2, differentiate sine, you get cos of 2x, all divided by sine 2x. And I can do it as a squared, I'll put that in brackets and square it, or I can just write it like this, it means the same thing. So here we end up getting negative 2 sine 2x, and it's squared, okay, and here we got minus 2 cos squared 2x, all divided by my sine squared 2x. Now remember the rule, I'm going to take out negative 2 as a factor, so I've got sine squared 2x plus cos squared 2x, all divided by the sine squared 2x. Now this is what you need to remember. Oops, I forgot my bracket there. This equals 1. Sine squared something plus cos squared something equals 1. Okay, so really this is 1 times negative 2. So we've got negative 2 sine squared 2x. So I found my derivative. The next part says, now integrate. Integrate 1 divided by sine 2x. So I'm going to change the colour here. Remember, if I integrate this, because there's my 1 divided by, I just got to get rid of this negative 2 by taking it out as a common number, and I get 1 divided by sine squared 2x. If I integrate this, I'm going to get back to this. So that's what I'm going to use. I'm going to use that knowledge, the integral from negative 2 sine squared 2x equals cos 2x divided by sine 2x. It has to equal that because we just differentiated this and got that answer. So if I integrate this, I must go back to that. Now take out the negative 2 and you get 1 divided by sine squared 2x equals cos 2x divided by sine 2x. And now this negative 2, it's a times here, divide on the other side, so I get the integral of 1 divided by sine squared 2x equals negative a half of cos 2x divided by sine 2x. Okay, you can leave it like that, you can put it as the 2 in the denominator, it's up to you. Any questions on that one? Okay, give you some time. Remember, I am putting these videos up, but it's always good for you guys to write it down. Okay. Can I clear it? The next question I will do is 11H question 4. Now, I'll do 4A. I'll leave you guys to try 4B and 4C. 4B and 4C is the little bit hard ones because I don't think I'll get time to do those. You should be able to do 4B after this one. 4C still might be that little bit harder. Okay, so this is 11H question 4 part A. And it says f of x equals that, find f dash of x. Okay, so that's the first thing I'm going to do. So f of x equals x log e of 2x. F dash of x. Okay, well I have a product here. Okay, this is times this, that's a product. So differentiate one, leave the other. I'm going to differentiate the first one. Derivative of x is 1 times, leave the second one, log e of 2x. Plus, swap them around. Leave the first one, x, times, differentiate the log e of 2x. Now, when I differentiate log e of 2x, remember, I just get 1 on x. Okay, and if you want the full steps to that, I'll show you. Differentiating here, you get 2, and then it becomes divided by that 2x, which simplifies down to 1 on x. So this is just log e of 2x plus 1. So I've found my derivative, f dash of x. Now it says integrate log e of 2x. So they want the integral of log e of 2x. Okay, this is what they want us to find. And I'm going to use the fact that f dash of x equals this. So I'm going to do it over here. So if I integrate f dash of x dx, I have to integrate log e of 2x plus 1 dx. Okay, so if I'm integrating this and I'm integrating that, and I'm just showing it there. Now integrate f dash just gives me f of x. That's what that gives me. These two I'm going to split. So the integral of log e of 2x, because I can, dx, plus the integral of 1 dx. So I've split them up. F dash of x, I know what f dash of x is, it's right here. F of x. F of x is right there. F of x is equal to x log e of 2x. Now, because I want to find this, because that's what they tell me, find the integral of log e of 2x, I'm going to move this one here, the integral of 1 to the other side. So I'm going to go minus the integral of 1 dx, and that will equal my integral of log e of 2x. I'm going to write this one first now, because I always like to have it first. So the integral of log e of 2x dx equals x log e of 2x minus, well, the integral of 1 is just x. So I have found the integral of log e of 2x. There's my answer. Any questions on that one? Okay, that's my 4a. As I said, I'll leave 4b and 4c. That is the hard one. Okay, I will get time to do this one here, 11H1G. So I'm just going to clear this.